Now you realize that anything you say can be used against you in court of law. All right. You got your notes? Yeah? Okay, so as you look through those notes, you should be able to see a couple things. You should be able to see where the breaks each day are and what's kind of the breaking point when you look through your notes.
I'm already at everything.
Yeah, your big template that has all your agenda stuff on it, what we're doing, all that stuff. So you'll know where one day starts and another day, or one day starts and ends and where another day starts. Okay? All right, so we are skipping chapter 1.
Or part 1.
We are going right into chapter 2. And believe it or not, a lot of it should be reviewed from physical science, so it should be overly confusing. All right. So matter. Matter is everything that makes up the earth that was created out of nothing. By God. Yeah. Now I want to talk about this here. What I just said, that matter makes up everything in the universe and was created out of nothing by God. That is a statement of faith. What do I mean by that?
We don't really have any proof.
Blasphemy. No, that he is true. That's correct. Brethren, can you prove with 100% of the doubt that there is a God?
No.
No. Can anybody here prove with 100% of doubt that there is a God?
No.
All right. First of all, don't whoa, parents! I'm not saying that there isn't a God. I'm saying that it takes an aspect of what? Faith. That is reality. It takes an aspect of faith. Now, do what we believe, is it blind faith?
No.
Is there things that support what we believe?
Yes.
Physical things
Yes.
in this universe that support what we believe?
Yes.
Yes, absolutely. But it is completely false for us to say that we can say 100% without a doubt that there is a God. It's just not possible. However, a lot of the scientists like to make blind comments as if they're 100% fact when it comes to evolution, right? They treat it like they know for sure. This is the truth. This is how it's always been. It's blanketed statement of infallibility. Okay? So first and foremost, we have to have a good understanding that, yeah, it does take an aspect of faith to believe what we believe. But if it didn't, then I think we'd have a whole lot of different things going on. Okay? So please understand that I'm not trying to say that there isn't evidence to support God. There absolutely is. Okay? But it does take an aspect of faith, and it really it gives us the right perspective. It gives us a humble perspective of how to approach things, right? Okay? It's not a prideful stance. We do it out of humility, which is what we should be doing, right? Okay, so what is matter?
Anything that has mass and takes up space.
And we really should probably have that memorized by now. Do we have it memorized? Brevin, you got that memorized?
Absolutely.
I had one of my top students get one question wrong on a test, and it was, what is matter? It was the only question he got wrong on the test. Yeah, he put anything that has matter and takes up space. Matter is anything that has matter and takes up space. So I felt bad because I knew he knew it, but I had to count wrong. Okay, so anything that has mass and takes up space, that's pretty much what? Everything, right? Okay, so we got this big vocab word here that pretty much encompasses everything. It would probably make sense that we should probably have some sort of classification scheme to break it up, break this big, broad statement up into some smaller subdivisions, correct? Okay, that's what we're going to get to today. We'll just introduce that today. We're actually going to talk about a few other things, but we need to be able to break it up into two really big categories. I don't think it's on your notes yet, but does anybody remember what those two big categories we break matter up into? If in physical science, when we started with matter up here, and we broke it up into two really big, still pretty big categories. Do you remember what those categories were? we'll get to it, but I'm just seeing if you remember any of it. Pure substances and mixtures. Oh. Oh boy, you gotta come back. I gotta read you every year. Pure substances and mixtures, okay? We'll talk more about pure substances and mixtures, and we'll break it up into what types of mixtures there are, what types of pure substances there are, atoms, molecules, things like that. All right, but before we do that, there are some other things that I do want to talk about. And again, this should still be reviewed for physical science. Physical properties. So this is a property of something. Okay, a property of matter that results from the position and characteristics of its particles, and that can be measured without causing a change in its identity. Now this is different from a physical change. This is a property. If I say gauge has some property, what am I really talking about? Can you give me a property that's physical for gauge that doesn't have anything to do with change?
Short. Someone was about to say.
Well, I think you could change that. If you cut it in half, you'd be shorter.
No, that's. Oh, okay. Smoking hot.
If you cut it in half, you'd still be smoking hot? Okay, sure.
Oh, yeah.
How about this? His hair's brown. I could cut his hair, but is it still brown?
Yeah.
I mean, but that's a chemical. That would be putting a chemical change into the mix here. Okay, so when I'm talking about a property, I'm talking about it's specific to the object. Okay, and I can do stuff to it physically, and it isn't going to change that property. Now, if I do something chemically to it, could it change it? Yes. Okay, so here's a few of these physical properties that you're probably used to. Okay, you're going to need to know probably this, at least a couple of these guys. Density. So we should know what density is at this point. Right? Basically the amount of stuff you can pack in a small space. Give me something that's really dense.
Mercury.
Okay? Okay, Jamie.
That little mercury thing.
Yeah, mercury's pretty dense. Give me something that's not dense. Ooh, I think I heard it. What did you say?
Oh, she said helium.
Oh, you said helium? Yeah, not dense. Okay? Now, it's really the amount of stuff you can pack in a small space. Amount of matter you can pack in a small space. So if I had a rock of a specific density and I cut it in half, would it change its density? Would it? It's a property of that rock. Okay? Am I changing something? Sure, but I'm not changing the property. I'm changing maybe its size. Okay? But I'm not changing its density. Okay, here's another one. Malleability. Okay, what's malleability in a nutshell? This is not a foreign word, I don't think, right?
Like solid.
What was that?
Kind of easy, pliable.
Pliable, that's a great word. I would say malleable and pliable kind of go pretty hand in hand together. If I can find this. I've shown you this before, but... Alright, so here's some lead, malleable, right? You're able to hammer it, easily move it, it's pliable. Okay, I've shown you this, most of you, before. I don't think this is new stuff, right? You've seen this? You're looking at it like you've never seen this before.
Yeah, you pulled it up.
Even I remember
That's
that.
right, but it's good now.
It's pliable, right? Now, if I were to take that and bend it so much and move it that it broke, would the two pieces still be malleable, pliable? Okay, so that is a physical property to that we can't change from a physical standpoint unless we did something chemically. Okay, you can pass that around. I think most of you have seen that before. I'm not going to linger on this too long. Ductility can be drawn to long wires. Metals are really kind of big culprits of this. An example would be your paper clips. Right? I can take this and get it back to its original wire-looking state. Straight wire, I guess. It's a little higher. Okay? But if I cut this in half, would it still have ductile properties? Okay. Oops. Conductive, the ability of a material to transfer heat or electricity well. no matter what I do to something metal, it's probably still going to be a good conductor, unless I did something chemical to it, chemically. Okay, so there's 4 of them. So if I ask you tomorrow with a bell ringer to list 4 common physical properties, would you be able to list those?
Using my notes.
Chemical properties. This one's a little bit more difficult because it has to do with it chemically. A property of matter that describes how one substance reacts in the presence of another. So that it involves a reaction. And an example of this would be saying that something is combustible. It's saying that if I take one thing and mix it with another thing, what's going to happen?
It's gonna.
Boom. Yeah, it's going to burn. Okay. A lot of times they'll say flammable would be another word. Okay. Alright. I don't want to linger too much on properties. I'm going to spend most of my time talking about the changes. The changes are the most important that we're going to spend, I think, really the majority of our time talking about. Okay, so a physical change, and again, this is review here. Changes that occur in a material without changing its what? Yeah, its identity. Okay, so before and after the change, I still have the same thing, same type of substance. Okay, give me an example of a physical change.
Cutting piece of paper.
Cut a piece of paper in half. You still got a piece of paper?
Yes.
Both ways, whether it's just to have 2 halves of a piece of paper, right? Okay, any other examples? Anybody else?
Is it?
Brevin, what do you think?
Oh, here it is.
Huh? You remember that?
Boiling water.
Boiling
Yep.
water. Oh, but
Yeah.
that's different, right?
No.
When you boil water, it's completely different thing, correct?
No.
Ah, the light bulb turned on for Quinlan. What? It's right there, isn't it? Yeah. Oh my goodness, guys. What? It's literally right here.
Example, boiling
It's
water.
boiling water. Oh, I did not look at it. I swear I did
I
not.
believe you. But guys, this happens a lot where I'll put something like, or similar to this on a test, maybe it's melting water. And a lot of times people think that's a chemical change. But the point is, how can you distinguish if it's a chemical or physical then?
It changes up.
If it's a different substance after. When you boil water, is it still water?
Yes.
Yes. It is. Okay? If you condense mercury, Lord help us if we did that, but if you condense mercury, it's still mercury. Okay? So the big thing here, and you might want to underline, highlight, whatever, identity change. Is there an identity change after this happens? Is it something different, or is it the same thing? That's the question you should ask yourself. Boiling water, there it is.
Okay.
I mean, I'm kind of glad you're not just looking through the notes just to find the answers. I want you to think. Okay, chemical change. So here we got without changing the identity. Here we got changes that result in a what?
Different material.
Now I will say some of these chemical changes, some of them will be pretty obvious, but others won't be quite as obvious, and you'll kind of just have to get some practice with some of these things. For example, iron rusting, that's a chemical change, but would you know that if you didn't know a little bit more information about it? It's a chemical reaction between your metal, the oxygen in the air, and some water. Okay, so it's a chemical reaction. So what you get is a new chemical substance if you looked at it from a subatomic level. Now, would you be able to see that? I mean, you could see something happen, but you won't really know unless we have maybe talked about some of these things. So there you go. Now there is some pretty big key words that you're going to look for, because eventually I'm going to give you a list of these things, and I want you to tell me whether it's a chemical or physical change. And if you see words like reacts with, if you see words like, you know, change, or if you see it change into something new, if you see, you know, you're looking for these key words that are going to give it away. And we'll give a couple examples here and see if we can figure it out. All right, here we go. I don't think I have the answers. I definitely don't have the answers on your notes. You're going to have to fill in the answers. But here's what I want you guys to do here to see how we're getting this. I want you to answer all these to the best of your ability, and then we'll kind of come together and work this out individually, each one individually, together as a group. But I just want to see, just kind of take this as like a pre-test or a pre-quiz where you're trying to treat it like it's a test or a quiz, but you're not getting graded on it, if that makes any sense. Alright, well, we got time. Let's look at 8 minutes. There's not much more that we have to do. We're just missing Tyler, right?
Oh, Tyler's?
Well, he's hurt his knee, so.
Correct.
He's in the class, but he's not currently here. Okay, so what questions should you be asking yourself when looking at these?
Is it something different? Am I right?
Am I right? That's the question you should ask before you start.
Oh. I thought you said after. I thought. Okay.
When you're reading it, you should be thinking, does this result in an identity change or does it not? Because that's really the two sides. And I realize there's a couple on here that may not be as easy as some of the others. Are we done? Okay, let's start the first one. Salt dissolving in water. Raise your hand if you think you got this one or you feel confident that you know the answer to this one. We got one person who's confident, or you know what?
All the
I'm not going to suggest that Gage is a leader, but I'm not saying you're not. I'm just not saying you are. Here's what I'm saying. I was reading a book on leadership, and it says that leaders don't necessarily come up with the ideas, but they're the ones that actually have the courage to do it. So you guys all probably have ideas, right? The question is, who's going to have the courage to do it?
Gage.
So, in this sense, Gage, yes, you are a leader. Let's hear it. Chemical. Okay, can you explain why?
Because after the fact, there's different combined substance where you cannot tell the difference between the salt or the water. It's just one thing.
Anybody disagree? Natalie? I think you're right.
You dang it!
Can you explain why you think it's physical? It's still salt water, so if I took and evaporated off the water, what would be left behind? Salt. And I know you probably wouldn't, unless you really thought about it, is the salt in the water chemically reacting, or is it just getting dissolved in the water surrounding the salt?
Just getting in there.
Okay, now we'll talk more about the dissolving process and what that looks like, but it's not a chemical reaction. Dissolving is like me taking a blanket and putting it over Marty. Can't see Marty, but Marty's still there. Okay, I don't know if that's the greatest example in the world, but I think it works well for me. Okay? So anytime you see the word dissolving, so here's a big buzzword, dissolving almost always is physical. Because you could undissolve something. It may not be easy to do it necessarily, but it can be done. And here's another great point. You know, sometimes leaders make mistakes. I forget what company it was, but they said that this guy took a risk and lost the company $10 million. And the CEO had this guy come in and talk to him, and he's like, well, should I turn in my resignation? He said, heck no, are you kidding me? I just spent $10 million educating you. Because he learned from his mistake, right? Wow.
That's rich.
That's cool. That's cool.
That's a good boss.
I'll never have a boss. They'll be like, okay, you're gone.
But you see, he understood that we need people that are willing to take risks and have courage to do it. Now, they can't be stupid, dumb things, but I'm sure that this guy was really well-meaning and had thought it all out, and it just didn't turn out the way that he had envisioned it. But to me, that's cool. All right. Anyways, nail rusts. Yeah, who thinks? They know. I kind of already gave it away. Brevin's all confident now.
Chemical.
Chemical, you are right. If you see rust, that's a buzzword for chemical. And again, you wouldn't know this unless we've talked about it now, but you're not going to know this if you hadn't been given information about it, right? It's a chemical reaction where your oxygen's reacting with water in the metal. And I don't even think it always has to have water available. But, yeah. Glass breaks. 2 in a row, brother. All right, what do you think?
Physical.
Okay, can you tell me why it's physical? Because I just broke this glass. That's pretty chemical to me.
Well, you're wrong.
Okay.
Because it's still glass after just a piece of
Okay, here's a big distinction I want you guys to understand here. I don't want you to just regurgitate information. I want you to know why. And you see, he explained why, he had a reason for why he made his comment on physical. Now, Gage had his reason was wrong, but that's okay. I want to know your thinking, right? I want you to explain why, because my tests are not going to be straight vocab. You're going to have to be able to apply it and be able to explain why. So, good job with your explanation there. Definitely physical. So, I don't know if this, what do we got? PCP. A piece of paper burns. This one's tough because do you really know what's going on with its identity? Okay, well, let's think about it. Let's think about this. If you took wood and you burned it, is the wood still there? That's probably what? It's probably chemical. Okay, so most often if you see burned, you're going, because what do you need for things to burn? Think about it.
Oxygen.
And I have oxygen, and it's a reaction that's happening when you're burning things, okay? So you can almost always, I would say always, assume that's going to be chemical if you see burns. But again, we're working on some buzzwords here to kind of help us identify. All right, iron and sulfur are heated and form a non-metallic shiny gray substance. All right. This one. Tanner?
Chemical.
It is chemical, but let me be very careful here. Does heated always mean chemical? Because I could heat up a glass of water and it's still water, right? But, yes, thank you. You found the key word here. So sometimes heat is all you need for a chemical reaction to occur, but other times all heat is doing is changing the temperature. So be very careful that a word can mean one thing in one context and be a little bit different in another. All right, let's try to work through this a little bit quicker just so we get the right answers. Vinegar reacts with water, big key word here, so it's what?
Chemical.
Chemical? What did I say? So it's chemical. Okay, water boils, we've already known that one. Physical, right? Okay, still water? Zinc when immersed in hydrochloric acid. Oh, there's a key word. What is it? So what is this going to be? Chemical. All right. Last thing, this word or this thing called shot peening. You should read this in your when you do your reading tonight. Shot peening is really kind of interesting because really what happens is they take these like little microscopic metal, I don't know, call them pellets, and they shoot them in the surface of metal, and so I don't know if it must be really hard because it gets into the gaps in metal. So it's like shooting these little subatomic BBs at that wall, and then going into the cracks of the solid, and it strengthens it. They do it on airplanes. To strengthen the airplane's wings and things, they shot peen. They shoot these little microscopic metal BBs, if you will, into the gaps of a solid. And we think, oh, there's no gaps in here. Oh no, there is gaps in here at a subatomic level. All right, read up more on that. And that is all. Just bring your homework on a piece of paper to me tomorrow. Yeah, it's going. Oh.